10 Ideas for Exploring Quantum Mechanics, Expanding Frontiers in the Quantum Realm. Quantum mechanics is a fascinating field that has revolutionized our understanding of the basic building blocks of nature. Its intricate and counterintuitive concepts continue to captivate researchers and scholars alike. In this video, we will explore 10 intriguing ideas for furthering our comprehension and delving deeper into the enigmatic world of quantum mechanics. 1. Quantum entanglement. One of the most striking features of quantum mechanics is entanglement, where two or more particles become deeply connected in ways that defy classical understanding. Investigating the behavior and applications of entangled states, such as quantum teleportation and superdense coding, can shed light on the fundamental principles of quantum information theory. 2. Quantum computing. Quantum computing offers a promising avenue for substantial computational advantages over classical computers. Exploring algorithms, error correction techniques, and hardware advancements can pave the way to harnessing the full potential of quantum computers, transforming fields like optimization, cryptography, and artificial intelligence. 3. Quantum sensing and metrology. Leveraging the inherent sensitivity of quantum systems, advancements in quantum sensing can lead to unprecedented precision measurements. Research in areas such as quantum clocks, magnetometers, and gravimeters can open doors to enhanced accuracy in navigation, environmental monitoring, and fundamental physics experiments. 4. Quantum communication. Quantum mechanics allows for secure transmission of information by utilizing quantum properties. Tasks like quantum key distribution, quantum secure direct communication, and quantum network protocols can bolster data security, revolutionize telecommunications, and form the backbone of a future quantum internet. 5. Foundations of quantum mechanics. An examination of the philosophical and interpretational aspects of quantum mechanics is crucial in deepening our comprehension. Exploring alternative interpretations, such as the many worlds interpretation or the Broglie Bohm theory, can shed light on the nature of measurement, observer effects, and the reality of quantum states. 6. Quantum simulation. Quantum simulators provide a unique way to study complex quantum phenomena that are otherwise intractable to simulate with classical computers. By emulating quantum systems using platforms like trapped ions, superconducting qubits, or ultra-cold atoms, researchers can address problems ranging from quantum chemistry to condensed matter physics. 7. Quantum machine learning. Combining quantum mechanics and machine learning has the potential to revolutionize both fields. Investigating quantum algorithms for classification, regression, and generative modeling can yield powerful tools for data analysis, pattern recognition, and optimization, inspiring novel approaches to tackling real-world challenges. 8. Quantum optics and quantum electrodynamics. Exploring the interaction of light with matter at the quantum level can unlock new phenomena and applications. Examining phenomena like cavity quantum electrodynamics, single photon sources, and quantum teleportation in optical systems can pave the way for advanced quantum technologies, such as quantum communication networks and quantum cryptography. 9. Quantum biology. Quantum phenomena could offer explanations for mysterious biological phenomena, including energy transfer in photosynthesis and avian magnetoreception. Investigating how quantum mechanics intertwines with biology can unravel the mechanisms behind these processes and inspire new bio-inspired technologies. 10. Quantum gravity. Merging quantum mechanics and general relativity remains one of the greatest challenges in theoretical physics. Exploring approaches like string theory, loop quantum gravity, and holography can help uncover a deeper understanding of the nature of spacetime and potentially unify our description of the quantum and gravitational realms. Conclusion. The 10 ideas presented here offer a glimpse into the expansive possibilities for exploring the vast and intricate landscape of quantum mechanics. By embracing these subjects in research and advancing our understanding, we can unlock immense potential for technological advancements and enhance our comprehension of the fundamental laws that govern the universe. Quantum mechanics truly represents a captivating and intellectually stimulating frontier that will continue to shape the landscape of modern science for years to come.